Assalamu alaikum guys, this is Mohammed Haris from Telecom Department 21TE37. Today is our lab manual number 3 of DSP by our lab instructor, given by our lab instructor Sir Engineer Dr. Jamil. So first of all we're going to perform this lab, and I've generated first, you will see the first video explaining the unit impulse, unit step and exponential function generated by an AI. Then I'm going to perform the lab tasks that are given to me. Thank you.
Greetings and salutations. Mohammed Haris here, a humble student of telecommunications, delving into the fascinating world of digital signal processing, or DSP for short. Today, we'll embark on a journey to understand three fundamental concepts: the unit impulse, the unit step, and exponentials. Output. First, we turn our attention to the unit impulse, also known as the Dirac delta function. It's a mathematical function that represents an infinitely short pulse carrying unit energy. Picture an arrow shooting straight up into the sky. The arrow is the impulse. It's there for an infinitesimally brief moment, but in that moment, it carries a significant amount of energy. This function plays a major role in the study of systems and signals. It's like the DNA of signals. No matter how complex a signal may be, it can always be broken down into a series of impulses. Next, we have the unit step function. Imagine standing at the edge of a cliff. One step forward, and you're off the edge. That's the essence of the unit step function. It's a function that is 0 before a certain point, and 1 after. It represents a sudden jump or transition. The unit step function is widely used in control systems and signal processing. It can represent the turning on of a switch, the sudden start of a machine, or the abrupt change in a signal. Finally, we come to exponentials. These are functions that involve a constant raised to a power. Exponential functions are like the superheroes of mathematics. They grow incredibly fast and they're everywhere, from finance to physics. In signal processing, exponentials are used to represent signals that grow or decay over time. They're also used to represent oscillating signals like waves and cycles. So to sum it all up, the unit impulse is like an arrow, brief but powerful. It's the building block of signals. The unit step is like stepping off a cliff, representing sudden transitions. And exponentials are like superheroes, representing growth, decay, and oscillations. These three concepts form the backbone of digital signal processing. Understanding them is crucial to mastering the subject. They help us represent and analyze signals in a way that makes sense. So, there you have it. A brief journey through the unit impulse, the unit step, and exponentials. Armed with this knowledge, you're well on your way to understanding the complexities of digital signal processing. Until next time, keep exploring and keep learning.
So guys, after watching the AI video, I hope you have understood the concept of representation of unit impulse, unit step, and exponential, and making signals out of data. So now moving forward to a lab task that is given to us. The basic objective of this lab is to representation of unit impulse function and unit step function, making unit step function out of unit impulse sequence and making an arbitrary signal out of deltas. So in first task, we are asked to make a function that we are going to save as imSequence.m. Okay, impulse, that means impulse sequence.m. So for that purpose, we're going to write our function, and this is our function that we're going to write. And after this, we are going to use this code to perform. So moving forward to our MATLAB Online. This is the first function, and as you can see, I have saved it with impulse sequence.m. And this is our code. It's a simple code of between two samples -5 to 5, and we're going to subplots, and we have used a stem function to plot this. Now after using the impulse sequence function, here's our output. As you can see here, that our output is given and unit impulse signals has been generated, as you can see here. In our next task, we are asked to make a function of a step sequence. For that, we are going to save it with step sequence.m. We're going to generate a function, and after that, we're going to use it in this code. So let's open MATLAB Online, and now I'm going to open, and I've generated this function as we were given, and I've saved it with step sequence.m. After that, I'm going to put in this code, and we're going to see what output are we gonna get. running this code, as you can see here, we get a step sequence response of our function. You can see here. Now moving forward to our next task. In our next task, we are asked to perform a sequence of a constructor to add impulse sequence over this function, and using the command pause, hold and hold off. For that purpose, I have generated a code using pause, hold. As you can see here, we have used impulse sequence that was given to us in our task 1, and we have used the stem function to perform. So after running this command, you can see here our function is given and unit step sequence is given to us. In our next task, we were given the same kind of function, and we were asked to make a task according to 1 using the task 1 function and construction. Ordered numbers at zeros were, and we were given this sequences, and using command of pause, hold and hold off. As we have used in this command, the stem function is used to subplot it, and pause, hold on and hold off function is used. So let's see the output that we are gonna get. As you can see, we were given an output is given signal 1, 2 and 3. So in our next task, we are asked to perform. For our task 5, we were given and we were asked to use the function of even and odd. So in this, you can see I have generated a code where the lengths are given. So after running this code, as you can see, we have our input signal, and this is the even part and this is the odd part of the signal. Now moving forward to our next and final task, we were asked for a sampling of a continuous signal, and after sampling, what will be the continuous signal. For that purpose, we are going to use this code, and we are going to get, this is our output of the signal. As you can see, this is our continuous signal, and this is our continuous signal after the sampling of the rate. So this is our first lab. Hope you have understood. Thank you.